Hi, everyone. Welcome to the first Rapids Academy session. We're going to be kicking off in a few minutes. There's been a bit of confusion because of the postponement, so bear with me. See you in a bit. All right, game on. Let me do a bit of AV setup here, and then we should be good to go. And I recognize that folks might be trickling in as we go here. Let's see here. Cool. And you should see me in the top right corner. All right, game on. Let me do a bit of AV setup here, and then we should be good. Okay. All right, and then that should fix the funny echo that was going on. Okay, cool. So welcome everyone. This is the first time we're actually doing this, and so what I appreciate as part of this is as things happen, anything worthwhile, just post in the YouTube chat or in the Rapids Slack. Let me actually post the link to the Rapids Slack in the YouTube. So let's see. If you go to rapids.ai, there's a community page, and so just go in there. And so a lot of us are actually there, and then within there, there's a channel called I want to say Rapids_Academy. Okay, yeah. So high level. First of all, thank you for everyone for attending. This is kind of like an exciting kickoff for not just me, Leo from Graphistry, but actually a bunch of the startups and folks behind the Rapids ecosystem in general. Just a kind of high level of the structure for today is essentially. Actually, let me fix the camera, or this is gonna look a little strange. Whoop. Bear with me here. Here we go. Give me a few more moments here as we fix this up. Should fix that. Let's put this guy here. And then let's get the Slack going. Cool. All right. So as things happen, feel free to chat in the YouTube Slack, in the YouTube chat. Note that that's going to be recorded, or in the Slack. The idea for today is going to be, we're going to spend about 40 minutes going over just kind of a nice like world tour of the Rapids universe. We're going to go through GPU regex, GPU visualization, GPU SQL. We're going to do a lot of it focused on log analytics. So we're going to go through a few different funding notebooks on that. It's all actually, if we go to learnrapids.com for Rapids Academy and go to the GitHub, it's actually all there. We'll be posting a little patch later today. And then we're going to take a 20-minute breather. And then folks who want to do the hands-on component, we're going to rally in the Slack channel. We're going to split off into groups of 4 or 5. And then we set up a fun free GPU environment with a fun little lab that I'll take you through. And so that'll be starting up in about an hour. Oh, somebody's noting that they can't hear me. Can anyone hear me on the screen on the stream, or is that on my end? I'm gonna just take a pause here on the chat to make sure folks can hear. See, is the auto okay? So Winston responded yes, so we're golden. Great. Okay, so yeah, let's dive through the recorded the kind of the recording part for the next 40 minutes, and then 20-minute breather, and then for the lab that actually will not be recorded, but we'll keep going on the YouTube. Okay, let's do it. All right, so I'm gonna what I want to share first is just a little bit of background, and let's hide this through. No slides today, so we're just going to be doing this all through Jupyter Notebooks. So the first thing I just want to share a little bit of background around Rapids and the GPU computing community. And earlier at the beginning of the year, I did a fun little chart. And basically, what I was kind of curious about is like, why is GPU computing so compelling right now, and like kind of what's been changing. And essentially what I did on the bottom here is 2 charts, one in terms of compute and the other in terms of memory, of just about how much, like, basically how much does a dollar go in terms of GPUs, and just how that's been changing. And so we all know that Moore's law is dead, and so the whole CPU computing stuff has been slowing down. And so what, oh, shoot, I think people don't see the chart. Let me give this a second here. What's going on? I want to make sure I'm sharing the right screen. Yeah, this is all like I feel like this is like all like a new, kind of like we're in a new era here. So everything's like a little tricky here. So I'm gonna stop the screen share. I'm gonna start it again and see what's going on. No, I'm just gonna share my full desktop here. It'll be less chaos. Let's share. And then I'm gonna hit the record button. And we should be recording, and just running on a slight delay here. Okay, I just want to confirm that you guys are seeing what you're supposed to be seeing, and then if we're good, we're good. Bam, all right, I see the chart. If the issues with audio again, just let me know. Okay, yeah, so let's kick this off. So before we go into the guide, I want to share what's going on just in the broader space of GPU versus CPU. And so at the beginning of the year, I just did a quick calculation of like what's the last 10 years of the kind of the cost effectiveness of GPU computing. So on the left, we have just in terms of the amount of compute, the floating point operations per second. And so this is like, like more compute per second, the better. And so what we're seeing is for kind of like over the last 10 years or so, it's been about a 30x increase for like on Amazon, like when you can launch their first GPU instances 10 years ago. For that same dollar, you can get about 30 times more over the last 10 years. I don't know if like anybody's been, a lot of folks have been buying computers over the last 10 years. They have not, on the CPU world, they have not improved 30x. Like I'm running on a MacBook from 5 years ago and or 3 or 4 years ago, and it is, if I buy a new one, it's not 30 times faster. So that's pretty cool. What actually ends up really important in the GPU world is how much RAM you have right on that GPU chip. So it doesn't matter if we have so many like cores, because if they're starved for memory, that means they don't actually have anything to do. And so what's kind of cool here on this same chart is for that same dollar, like how many gigs of RAM do we get? And what we're basically seeing is we went from that 1.4 to 30 to about 31. So this is again like that 20-30x increase over the last 10 years for cloud GPUs. So that same dollar, again, we're not seeing that same thing for CPU RAM. So while Moore's law is indeed dead in the CPU world, it's still alive and kicking here. And so, and kind of what that tells us as folks trying to do, Hadoop, Spark, that kind of workload, eventually the GPU stuff just is more compelling. And for the folks who from the Rapids ecosystem who are tuning in today, I actually want to say big congratulations. Where I think about two weeks ago you went public, where for the first time a GPU stack officially beat the Hadoop ecosystem on kind of one of the main database benchmarks, the TPC BB benchmarks. So and I think it was actually by a wide margin, anywhere like different workloads from 20x to even like 400x. So and that's kind of what's going on with this chart. And because it's in Amazon, Google, Azure, anyone can do this stuff now. So, well, what is Rapids? I keep using that phrase. So some folks already know it, some don't. What's going on here is basically we have all those like CPU in memory stuff like pandas, Spark, SQL, Dask, NumPy. Those are a lot of the core building blocks. And then when you're actually getting into application work, we might have stuff on top. You might have machine learning libraries in Scikit. Graphistry, we do a lot of graph analytics. So folks might have been using something like NetworkX. We also do a lot of visualization. So you might have been using something like Plotly or Bokeh or Gephi. Those are actually like, a lot of those were built for convenience. And so they had kind of nice APIs or nice-ish APIs. They did try to do some performance, but a lot of the winners ended up being actually about usability. What's cool with the Rapids ecosystem is one of the decisions through a lot of the projects has been just maintaining API compatibility with the CPU stuff. So if you knew pandas for Python pandas, you actually know a good chunk of the cuDF library. If you knew SQL because you're doing Spark SQL, congratulations, you now know GPU SQL, or like you're 80% there. So that's going to be a lot of today. I'll skip this bit on the graphs. Like a graphs tree, we do think about a lot about, if you have a lot of rows or columns in your data, like how do you see the correlations? And that ends up being a lot of graph analytics. So, but you'll see that in examples. So today, for this first portion, what I want to go, I'm going to go through 3 examples. Again, they're all on GitHub. First one, we're going to be doing a bunch of SQL. Doing GPU SQL, we're going to load in more memory than a GPU has, so that'll be pretty fun. And then we're going to go all the way from looking at logs in SQL to actually visualizing them. After that, the second one, we're going to do something similar, but then we're going to do, when we're going to be looking at those records, in that case, we're going to be looking at domain records. We're going to do 2 different things. One is we're going to throw a whole battery of graph analytics at them and see how many we could do quickly. And then the second thing we're going to do, and this still like, I'm personally coming from the academic land, like where I remember writing research papers about this stuff 10 years ago. We're actually going to write regex and have that run on the GPU, and it's going to be no big deal. And then we'll visualize the result. And then for the last one, we're going to touch a bit more on the machine learning side. And so we're going to show an example where if you have a bunch of event records, in this case, we're going to be doing some COVID misinformation stuff. If you have a bunch of event records, we're going to show how to just automatically find the patterns in it and then plot them out and do end-to-end GPU. So this should be a pretty fun one. And then a reminder, this is cool. Take a 20-minute breather and then come back, and then you'll actually do a hands-on for the lab portion. So all right, so let's kick it off. And then as we go along, this is like a new era, new medium. It's kind of cool that we can do this as like an interactive chat. So if you have any questions as we're going along or anything like that, just chat in the Slack or in the YouTube. Okay, so let's kick it off with the log analysis. So this is going to be all on the GitHub. This is tutorial 1. And the technologies we're going to use for this one is primarily going to be Blazing SQL for the analytics. And then we're going to dump it into Graphistry first we're going to dump it into the Jupyter Notebook to see the result. And then second, we're going to, from the notebook, drop it into Graphistry to actually see it as a pretty picture and see what's going on. And all this stuff you can actually do free. So we'll take it through you in the lab. But if you're not joining, then go to app.blazingsql.com. You can get you get a free GPU notebook session here that's already set up for the RAPIDS environment. Go to learnrapids.com to find our GitHub to get the tutorial. And then for Graphistry, the visualization stuff, if you go to our homepage here, Get Started, we launched this thing called Graphistry Hub, where you can just get a free online account and play with data. Okay, so for the first one, this data set is pretty fun. So what we're going to be looking at is about 53 gigabytes of logs. So this is something that normally, like, I'd feel a little nervous about opening in Excel or even actually in Jupyter with pandas. So this is like a real amount of data. It's like 53 gigabytes. It's actually, I think it might even be more than the CPU RAM on the box we're on. I actually have no idea. The GPU we're going to be running on is actually, again, I think it's probably 10 to 16 gigabytes of GPU RAM on the box we're running on. So this doesn't even fit in the GPU. So this is a really fun example for the analysis. So, and also, so as we kick it off, one of the kind of really interesting things here, all that data is actually already split between, looks like, man, I don't know, 50, 100 files here, 58 files. And so the first thing when we start Blazing SQL, it's actually not a database. Think of it similar to like starting a pandas session. Like it's just like this, it's just like this in-memory ephemeral thing. And so we just say, hey, we want to start kind of like one of these scripty SQL sessions. Here's where all 58 files are. We just pass them in, just the URL. They all have to have the same format to be considered part of that same table. We're going to give it the name logs, and then bam, I have 4 seconds later, I've got a table of 53 gigabytes of logs that's now GPU accessible. Keep in mind, it hasn't actually moved to the GPU. Right now, it's just still sitting in S3 buckets. And it's going to be Blazing SQL's job to kind of move data in and out of the GPU memory as we go along. Actually, here's where we actually officially, oh, I guess what was going on here is I also wanted to just do a subset of 10 million. Like that's still a lot of data for somebody like Pandas, but like for our stuff, it's a nice way to, I often like to have like maybe 100,000 or a million subset just to play with before I do like, the billion, whatever scale. So if you know SQL, you know Blazing SQL. It's actually more about making sure performance works out or that you're in the right, like the subset that they currently support. And so, for example, if I just want to ask how many IP addresses are in my logs, I could just count normal SQL. And we saw in this case, wow, okay, we have about, this is actually about 50, 60 million rows. So they're just counting the number of rows. I could have done the same thing as distinct count and asked how many unique IPs, and that's it. Likewise, if I could just select star, I can see everything. So the data set we're doing today is pretty typical of network and security analytics, where we're using something called Zeek, used to be called Bro, but it's basically a bunch of different types of network connection logs. And so we can see all sorts of stuff about like HTTP and SSH and things like that. So if you haven't seen it before, check it out. It's pretty fun. So a lot of like in the beginning of the tutorial, it's basically stuff that you'd expect. Like can you sort? Can you tick? Like let's say I just wanted to see SSH activity. Could I just filter by port 22? And it's not so bad. And you're seeing here it's all running through. What I wanted to actually share was this big query here, where whether I'm in Spark or Splunk or Blazing SQL or a lot of other network analysis, but I found that a lot of my queries end up looking like a variant of the one I'm about to show. And so for me, this is one of those. If I could do this query, I could basically do a lot of the analytics on whatever stack I'm on. And so what's going on with this one, the meat of it is really right here. First is if we're looking at a bunch of like computers or whatever talking to each other, we're going to just want to first group by the source and dest IP. Sometimes I might also do something like source port, something like that as well. And then now I have basically, I can now start asking questions about, hey, when this computer or this application talked to that application or this user connected to that user, tell me some information about it. So if I'm doing for network performance, I might ask about packet loss or like the sum of packets going through. If I'm doing in a security context, I might ask about like, hey, was there any activity? What was this? How much data came in, come out, like for exfiltration? I might ask like, how many distinct ports? Could I do a distinct count of the number of ports to see, what was actually going on, stuff like that. And so this is just kind of an example of that. And then we kind of ran it through. And you can do all sorts of variants. Yeah, so here you see that I went on and did a case where I was curious about, let's just split it based on all the application ports, like the low ports, things like that. So I see actually somebody here is asking about how do the queries compare to something like Spark. I don't know if we have anybody from the Blazing SQL team here who might give like a more like official answer. The way that I think about it is generally maybe if you think about per dollar, maybe like a 10x. The issue there's kind of like different axes of it. So the first thing is like for the same dollar, like you can pick how many GPUs you run. So Blazing SQL, you could do like one GPU, multiple GPU. But basically, when you lock the the amount of energy or the amount of dollar you're paying, that means you get a certain amount of compute, you get a certain amount of RAM, things like that. And so then generally, as long as you can keep it all in memory, the intuition is Spark has to move data and shuffle data between computers. Rapids, generally, if you've got a bunch of GPUs on the same box together, you don't need to pay that data movement cost at all. Just it's going to come in and stay in on that same node. So not only do you get the GPU speed up, but you actually skip all that data movement. And actually, a good example where I want to share using that is, for example, for that one, I just ran right ahead a query to do that same shape of let me see all the port like computer communications, but I filtered that down to just the SSH activity. I wanted to see for this network what that looked like. When we got that table back, and this is where something like Rapids starts looking different from something like Spark. Um, Remember, all of this is running on like I'm running on the notebook on a box with a bunch of GPUs. Actually, I think just one GPU on this one. So when I'm working in that notebook, I'm actually looking at the GPU and how much memory is there. And so in this case, when I get that, when Blazing SQL gives me back all that SSH activity and the summary of it, that's actually a pointer to GPU memory. And so when I jump to Graphistry, if I actually had this box configured a bit better, and I said, "Hey, Graphistry, plot that table." If I had Graphistry running on the same GPU box, I wouldn't have to upload the data anywhere. And so, like, it's just even ignoring GPUs, like you just don't pay all that data movement cost that you do with the Spark world and the NoSQL world. So in this case, let's take a look. We're actually running Graphistry elsewhere. Another cool thing about the Rapids ecosystem is very early on, I made the call to rally around a technology called Apache Arrow, and it was kind of co-designed in parallel with Rapids to make sure it could kind of do the GPU stuff. And so basically in this case, when we take our data frame of all the SQL results, just think of all those different columns, it's actually binary data. And so we're going to move that binary data to Graphistry. We hit .plot, that moves it as binary data rather than JSON or CSV. And that means on the Graphistry side, when I load that in, it actually goes straight to the GPU. We don't really have to do like parsing and stuff like that. We did some validation and stuff, but we're actually able to do all of that on GPU. And so generally, when this case, like we actually have a small network, it looks like a network of results, but you'll be seeing later when we get like, let's say 100,000 or a million results back, it actually, all that data transfer time, even across computers, is actually pretty fast because it's all binary data and it's just memory copied straight to the GPU. And so there have been really cool numbers about that. But one local benchmark we had was like, same network, maybe like 100 million things in about a second or two. So yeah, so in this case, what we got is the summary of all that, the Zeek network data. So when we got that, the Blazing SQL result, we're seeing all those byte sums. You know, I can ask like, hey, what was the biggest byte transfer look like? Let's see if we can see which edge that was. Zoom out a bit. Yeah, it looks like so over here we had some some chunk of network had some pretty heavy activity. Whoop. I think my poor little laptop is getting a little overwhelmed here. But yeah, so what we're seeing is one of these links here was super heavy, and we're seeing that around that link, we actually see there's actually another computer that seems to be part of that cluster. And so we can kind of look at these 4 different flows and try to, we might want to piece together what's going on. And so this ends up being a nice, hopefully you're getting a feel for the full ecosystem here. So this ends up being pretty cool. Okay. So let's jump to the next one here. So this was a quick analysis that popped out of the COVID threat intelligence project, where a bunch of cybersecurity analysts have been pulling together threat intelligence around a bunch of COVID attacks. It ends up being a lot of phishing, spam. There's some targeted attacks. A lot of it's a lot of fraudulent domain names, like, for example, people selling fake protective equipment, things like that. There's just like a lot of badness happening. And so Alien Vaults, Sophos, a bunch of good companies help with that. And so here what we're going to do is, given all the new COVID domains that got registered and were getting shared over email, online, places like that, we had the passive DNS data of when they got registered, And so this could feed into various kinds of analytics and investigations of, what's going on. Are these domains good or bad? The reason I wanted to go through this example here was, again, given a bunch of all these like log records, um, I wanted to show kind of two things. The first one is doing regex and running regex on a GPU. And then the second thing I wanted to show was then doing graph analytics just straight in the notebook, and kind of working on, given all that event data, seeing what correlations and kind of scores and things we could do. So the first thing did, and maybe the kind of the pause point here is, in a lot of big data, machine learning, data science, whatever, the reality is like 80% of our time is like just loading in data and then wrangling it. And so being able to do GPU regex over like 50 gigabytes of data is actually an important thing, right? And so in this case, for example, the data format we got it in was, we got a bunch of IPs. We had to, what we want to check is something an IP? And if so, maybe we can want to change the format into something faster. And things like that. And so here, and we just did a quick simple regex. This is like an IPv4 where there are 4 dots in it, like there's 4 numbers with dots in it. And if that's the case, like that's just the standard regex here. We just take that column of whether it's the domain name and then whatever the DNS record responds with. If it responds with an IP versus domain, then we'll get an answer. Is the query your domain an IP? And the amazing thing about this is like it's boring. That like this is basically, if I was writing pandas, this is what it would look like. I would have taken my table of IPs. Oh, actually, I do want to make a note. Like when I read in the CSV here, we're actually not using Blazing SQL anymore. Now we're just using raw cuDF. So cuDF is kind of how Python pandas is sort of the Swiss Army knife of working with tables in Python. cuDF is the GPU implementation, essentially, of pandas. And so you just load into CSV, whatever size it is. In this case, we just loaded in 300,000 records. It just loaded in. You don't worry about it. And then now we could do fun stuff like, okay, on the column of queries and answers, could we do the regex? And it just works. Like it's exciting how underwhelming this is. Like 2 years ago, you can do this. Okay. So now that we have that, we can actually start asking questions about, like, basically, if you think about, for example, how Google works, the early versions of Google, they have this notion of PageRank where you can ask like, hey, which page is the most important? So if you have a search result, which are the important ones? Things like that. And then there's like a really fun wide world of graph analytics algorithms. We're actually going to probably maybe sometime late August, we're thinking about doing a second session, just like, I'll just come back and talk a lot about graph stuff. But the fun thing here is we're just going to basically run all of them. And one of the fun things with GPUs is if it's fast enough, you don't need to really worry and stress about exactly what you're doing. You can just iterate. And so in this case, we're going to use cuGraph, which is essentially the GPU accelerated version of NetworkX, which is a Python graph library, except for now you can deal with 1 billion nodes and edges on the same GPU. And all we're going to do is take that table of domains and the whatever the DNS record maps to. We're going to take that result and then turn it into a cuGraph object. So we're going to change it from one GPU representation to another. That's just something whatever cuGraph kind of likes. And then once we've done that, and you can, I guess we didn't have the timing information, but this is fast. So let me just actually run it live. So we're going to load in the CSV file, 300 milliseconds. We're going to run the GPU regex, less than 100 milliseconds. I don't even know what this one's doing. I think we're just doing some pretty printing here, so that's probably less interesting. Oh, actually, we're actually here. This is a good example. We're actually going from the GPU to the CPU. So you just do 2 pandas, and now it's just a regular pandas object. In this case, I wanted to do some stuff that I wasn't really sure how to do in the GPU quickly, and so I was able to just do it using my normal CPU stuff. Of course, pandas is slow. Now it's like 10x, 100x slower than all the numbers I've shown you before, but you could still do it. So it's nice to have that escape hatch. Same thing with Blazing SQL. You could always do that. But then what I want to show is then for that GPU table of all of our domains, super fast to turn that into the new graph representation that cuGraph wants. And then where it gets really fun is this one where I could try to be very careful with which graph algorithm I want, like, page graph or degree or a core number or connected component analysis, Louvain, or I could just run all of them. And so I found out increasingly for a lot of analysis I do, I just go and I just run all the graph algorithms. And then for every domain or whatever, I just have all of the results. And then once I'm in the visual tool, I could then just kind of play with them and see what they're doing. And that's kind of what the rest of the notebook does, is then we just take the cuGraph object and plot it out. Actually, in the interest of time, I realize that we're coming up on the clock here. I actually want to jump to the last one. And this one we'll do much more visually. And for the last one, I want to jump to the machine learning side of the RAPIDS ecosystem. So in parallel to a lot of these GPU analytics stuff was the deep learning world. So a lot of people, when you think machine learning, you think maybe exclusively deep learning. And RAPIDS does actually interop there, where you can use RAPIDS to wrangle your data, move it into the deep learning framework, get your a few enrichment results from the deep learning, and then add that back to your data table for analysis back in RAPIDS. But the reality is, about half the time you want deep learning, half the time you actually want like something like a random forest or other methods. Like if you look at top Kaggle competitions, it's always this kind of toss up, and it really depends on the domain you're working in. If you're doing vision, probably deep learning, but if not, who knows? So what I want to share here is something that we actually end up using a lot, is something called UMAP. And let's switch tabs here. And this is another COVID analysis that we were doing. In this case, we were looking at social media interactions, so communications on Twitter, things like that. This could just as easily been an email analysis, something like that. And I'm actually going to jump straight to the visual, to what's going on, to explain this one. So what's going on in this visual is every dot is, let's reload here. As you see, I really like doing live demos for this stuff. Like, one of the fun things about a lot of the GPU computing world is that, like, because things are so fast, we could just do it live. So in this case, and you can kind of interact live, like, instead of like waiting minutes or whatever for like your Hadoop or Spark job. Oftentimes, when you get it going smoothly, it's more about like seconds. Okay, so for this one, what I wanted to share is what we're doing with something called Project Domino, where we're looking at COVID misinformation, in particular different accounts on Twitter doing misinformation. And this is kind of a regular setup where you have a bunch of entity, like a machine learning setup, where you have a bunch of entities and you might have a bunch of like features for them. So in this case, we had a bunch of Twitter accounts, and then we were kind of looking at which conspiracy theories they mentioned. So if you're like, let's say in Spark or Splunk or tool like that, you might have like a bunch of IPs or a bunch of user accounts. And then you might have like a bunch of information like, which country was it in, or how many messages were there. In Twitter, what we care about is like maybe the timestamps they're active, how many friends they have, and in this case, what are the things they're talking about. As soon as we have that table of ones and zeros, or actually, or just numbers in general for each entity, what we run is something called UMAP. And normally UMAP, I always forget what it's called. It's like universal manifold something or other. It's if you're familiar with TSNE or PCA, just think of it as like 5-10 years after all that stuff. What's cool about UMAP is, by default, with very little work, what you get is something that looks like this. You get, for every entity, you'll kind of get put on screen somewhere, and you can do it to a 2D, 3D, whatever projection. And so just based on the topics, what we're getting is, for each Twitter account, who are they kind of like, which topic, like, not only which Twitter accounts are talking about the same conspiracies, it's also sort of like if you think about like an audio wave, like, and you ask like, are two songs like not only singing about the same thing, but actually in the same way. Like, they have high bass and low treble, something like that. And so what UMAP is able to do for us is answer, hey, all these accounts, they're both talking about QAnon and chloroquine, or however you pronounce that. But when they're closer together, what that means, they're not only talking about the same thing, but actually in the same intensities. Like maybe these ones are talking a lot about QAnon, and these ones maybe over here are only talking a little. And actually, maybe they're talking more about this ID 2020. And you can kind of get this not even exact, instead of just exact match, you get a nice fuzzy weighted match, and the distance kind of tells you how far. Then the thing we do after that is you can then take the UMAP, and then we can just draw edges between things that are close. And so now an edge between any two nodes in these two Twitter accounts doesn't mean that they're friends. They may have never mentioned one another, never followed one another. But if there's an edge, that means they sort of are talking about the same thing. And if there's a lot of close and heavy edges, that means they're actually almost like bots doing exactly the same behavior. And so if you're doing something like a bot analysis, this actually ends up being quite interesting. Or let's say you have like an outage and you have like a fleet with like replicated misbehaviors, this would actually kind of start classifying things in the same way. So it ends up being cool. Because it's all living on GPUs, so this is where the interactivity comes in. We have about 100,000 edges on screen. We're actually just clustering them live based off of those inferred connections, and we can play with them. And again, all that data. So in the case of the QAnon stuff, we might want to ask, let's make the ones that talk about QAnon a lot bigger, and then for the QAnon conspiracy, let's also make them hot. Like let's make them pop out a bit more. And so we can kind of see for all the COVID misinformation and conspiracy Twitter, we're seeing QAnon showed up a lot. Like it's all kind of some shade of pink, but then some areas were hotter than others. And behind the scenes, we're doing all the GPU stuff on the server. So anyway, hopefully this has been kind of a fun introduction to Rapids Academy and to the Rapids universe. This has been an experiment. It's the first one we're doing. My hope today was that basically, if you already knew Python, the Python data world, this would feel kind of somewhat familiar, just a little different because of the GPU parts. So I was hoping that seeing loading in big data sets, doing regex, doing data frames, doing machine learning stuff, all of that should have felt familiar, just and even actually at the level of APIs, and actually, but now you can see that it's quite approachable. If you're already in that world, you actually may have been even seeing to the level that, hey, actually, I already know that exact API. This is I totally get what you did, and then you might be thinking more at the level of like, hey, well, how do I deal with multi-GPU, or how do I deal with multiple nodes of GPU? And you're starting to think more about that stuff. We're actually going to be holding future sessions over the next few months, kind of doing that progression. So I encourage you to join for those. For folks who are hanging on, I encourage you to, like I'll close up in a couple minutes, but take a 10-20 minute break. We'll be back at noon Pacific, 3 p.m. Eastern, and then we'll start the lab portion. Again, just head to the rapids.ai Slack, and we'll kind of start splitting folks up into groups for the lab portion and post instructions there. I'll still be doing the, as we go through that, I'll still be doing the YouTube live stream, so you can kind of see that, just so we won't be recording it. With that, especially for folks who need to, who plan to stay on for the free lab in 20 minutes, I encourage you to take a break. For everyone else, if you want to just hang out, ask questions, looks like we have Winston from the Blazing SQL team. I bet we have some Rapids folks. Actually see Sindre over from the Project Dominoes with us. So if you have any questions, let me know. I'm gonna stop the recording right now, but I'll be hanging out in the Slack or in the YouTube. Just feel free to ask questions, anything like that. All right, thanks everyone, and appreciate you joining for the first one with us. All right. Starting to get back on track here. Yeah, so for everybody still on the YouTube, let's jump into the Rapids AI Slack if you're not there, and we'll use that to organize and team up. So I think for the training, I think we were only going to have like 10 or 20 people for this portion. Unclear, but maybe we can do a quick sound off on the Slack. Maybe post a quick message. Depending on how we might actually just keep everybody as one big group. So do a quick welcome everyone in the training. If you're joining, can you please give a thumbs up so we can estimate for splitting into groups? So someone's, let me post that in YouTube. Looks like somebody was having an issue there. Let's see if other folks were. Slack. If you have. Okay, so let's see. All right, folks are signing in. Let's see. Yeah, if we can keep everyone in one big group, that's actually logistically way easier. We're trying to figure out, all right, how are we gonna split people into groups, do channels? And it looks like we'll be okay. Good. So, all right, so it looks like we're actually pretty good here. I think we could just keep everybody in one group and then not worry about it. And that's great. Okay, so here's how this is gonna work. If you go to app.blazingsequel.com, it'll ask you to sign in, and it'll just basically be a Jupyter instance. I'll get to that in a second if you haven't done that before. But basically, go to app.blazingsequel.com. You'll just kind of do a login. It'll take you to your kind of sandbox. You're actually going to be on a shared GPU with folks, so we'll see how that goes. I think we have a few GPUs on this one, so we'll see. Okay, yeah, I'm on a bit of a delay with the YouTube, but basically you're going to see that environment. I'll show you in a second how to get the data. The second thing you're going to want to do, so first you do that. The next thing you're going to want to do, I'll get the command here, is we're going to want to copy in the training, so you have that all right there. You can actually also run all this stuff on your own after, like on your own personal on-prem box, or spin up an AMI, like Graphistry has one on the marketplace that's already set up. But basically, what you're going to want to do is, this is actually a hack, but it works pretty good. You're going to go in, and then you're going to run this command. I'll post it both in the Slack and in the YouTube. So once you're logged in, you're going to run that command. What that's going to do is it's going to create a folder called Rapids Academy here. This is going to give you everything. This is our first session, so you're just going to get the security tour session. And we're going to be going through the notebooks called Lab and Lab Answers. I set up a series of tasks that we're just kind of going to walk through. The one other piece of setup here, and also a couple of things to note here. Also note it should say when it's picking environment, pick Rapids stable for kind of the Python GPU environment you're going to want to use. And then the other thing is, if you don't have a Graphistry account, you can go to graphistry.com get started. And that's going to let you, we recently launched something we're experimenting with called Graphistry Hub. It's sort of like a nightly build of Graphistry right now. So it's a little unstable, a little buggy compared to normal. But basically create a free API account, kind of same thing, you just log in. For this session, we actually have a slightly updated one where there might be a few bug fixes, but you can also go to, I'll post the link here. So either graphistry.com get started, they'll do your public hub account, and then we have a box that will just go away afterwards, but it's RA1, Rapids Academy 1, to just but it has some bug fixes. You can use either one, but basically you're gonna go there, get an API key, and you'll be able to use our GPU servers for the visualization part. So yeah, maybe as a quick checkpoint, can folks give me a thumbs up either in the YouTube or in the Slack if you're able to do that, or a thumbs down if you're having issues. Just give me feedback either way so I know what's going on. And then I'll get into how it's going. Then afterwards, I'll get into how we're gonna organize the session here. Cool. All right, we got the first person that worked. All right, do we got more? How's it going? Basically, where I want you to get is when you go in all the way into the Rapids Academy security tour, when you get to that notebook that says lab. Cool. All right, we got someone clone the repo. And this first session is a bit of a journey. We're using this to also see how these training sessions go in general. So thank you for kind of taking that journey with us. So any feedback or whatever at the end of this will definitely be appreciated. Cool. All right, looking like folks are starting to get to, they are getting to the right point there. Yeah, and for the, I didn't put the link to the Graphistry part, so let me put that in the YouTube. Here's so if you want the public hub, the account will stay on after, but the slightly less buggy version is this guy we put up this morning. For that, I could actually show you what's going on. If I go to say here, the main thing is once you log in, and the main thing, you'll have your username password, but also you get one of these like JWT tokens that let you do some cool stuff. Cool. All right. Slowly getting to the finish line. I think this is actually going to be one of the hardest parts of the whole lab, is actually just getting these, getting the accounts and whatever, getting it set up on the GPU boxes. Okay, all right. So folks are starting to hit code errors. Don't worry about it. I'll walk you through to that in a second, what's going on there. So I'm gonna walk through a little bit of setup with you guys, and then we're gonna move into the first tasks. So I want to give folks about like 1 or 2 more minutes, and then we're gonna I'm gonna start going into it. Yeah, someone's asking Graphistry Hub versus RA1. You could use either server. We're just worried about load or whatever. I don't think we have a heavy load today, but Graphistry Hub is the one that's going to stick around after. So and what we're going to want to get from that account is the API key. And then from Graphistry, what's going on? When you log in on your dashboard, should say somewhere something called our 2.0 API, and that's going to have this like short-lived JWT token. Basically, this is the thing that expires every hour, and you just renew it every hour. You can also log in with your username password. Okay. Oh, someone's asking how to join the Slack channel. That helps. I'll just show that super quick. If you go to Rapids, go to the community, and then I'll post this link here just for, because they change it now and then. But then you go to the way to the bottom, there's like a Slack channel link. That's the one you want. I would post the link in Slack, but if you're ready in Slack, you don't need the link. And then once you're in there, then go to the Rapids. Okay. Cool. All right. So it's been about 5 minutes. If you're still stuck or something weird's happening, just post on the YouTube or the Slack chat, and then like me or someone will help you out. So I want to walk through first like a quick like hello world of notebooks, and then including with a bit of the GPU stuff, and then I want to work through the bit of setup, and then after that we'll go through the tasks. The idea is when we do the tasks, I'll introduce each task. We have it kind of set up to there's like a reference, and then there's like a task, and then I'll kind of introduce it, give folks like 5-10 minutes, and then we'll kind of go back and recap. There's also a lab answers for anything you get stuck on. All right, so let's kick it off. If you scroll down, oh, someone's asking about the import token. I'll show you, excuse me. I'll show you how all that stuff works for the second part of the setup. First, I just want to make sure everyone is used to the notebook environment. Then we'll scroll up and do it. So if you scroll down in the lab one, if you open up lab one in your environment, scroll down to a quick demo just to get everyone on the same page. We have commented out a few things, but basically, if you uncomment it, the first one, we're going to run basically make the variable x assigned to 1 + 1 and print it out. If you hit, I think Shift Enter or Control Enter, that will kind of run it and then move you to the next cell. And then also kind of cool, you can actually put bash commands like shell commands in. And so if you look at this next cell here, I'm actually escaping Python. I'm actually jumping into bash, and you're kind of seeing, you know, I'm seeing all the files and stuff. So, and then kind of pretty cool also, I'm going to run 2 commands here. The first one is if you want to see what's going on with your GPU, wherever you are on the command line, a notebook, you can always run NVIDIA-SMI. And the things to look at here are you're seeing which processes are running. So it's looking like this is probably a Docker container, so you might not actually see all the processes, but we're seeing 2 processes combined about 1 GB of the GPU memory. The other things to look at, looks like within the container, we're running CUDA 10.2, the NVIDIA driver 440. The type of GPU is a Tesla T4. So these are a little slow, I think, on doubles, but fast on singles. And we have a total of 15 GB of RAM to play with. If we have multiple GPUs, or multiple users, this might be higher than 1.8. Someone's asking, can you use GPUs after? Yes. So app.blazing.sql is just free and open for everyone. You can keep using that after. Likewise, Graphistry Hub, your account is free and open. You can keep using the GPUs there. For Graphistry, it's kind of like GitHub, where we're doing open data stuff and OSINT and all that stuff. Like open data science is open, and then we're going to be doing some other stuff on the closed stuff. I'm not sure. I think you're same thing kind of with Blazing. You shouldn't put proprietary data into their servers or PII or anything that will get people sued. RA1, Graphistry, that one's going to go down after. We just wanted a backup instance. Okay, I want to show one more thing before we go into setup, which is if you go on the left panel here, we're in something called, somebody says no processes found. A thing that might be going on there is if you look on the top right, you might need to start a stable RAPIDS kernel. So make sure you're in a stable RAPIDS kernel. It might be no GPU or something like that. If you're still stuck and that didn't work, and also what you might be able to do is kernel, whenever things go sideways, you can kill the process and reconnect to your, restart the Python process and reconnect to the GPU. Just go to kernel and then restart kernel. Okay, so I want to share one more thing here. If you go, so we're in something called Jupyter Lab. Normal Jupyter notebooks are just these notebooks on the right, but in something called Jupyter Lab, it's kind of just like dashboardy environment with other stuff. Something that a lot of the RAPIDS environments come decked out with is this GPU dashboard. So I don't really know what this icon is on the left, to be honest. Maybe it's like represents a GPU card, I guess. I think the one I liked is, you can kind of click through all of them to explore, but I think the one that we're going to I recommend mostly using today is the GPU resources. And the thing to look at here is, because I think where everyone's just on one GPU, you can see what percentage of the GPU we're using, and then what percentage of the GPU memory we're using. You can kind of see we're on a 14 gig GPU, and it's running very low right now. So maybe it's idling at 1 or 2 gigs. So this is pretty light. Okay, so let's go back to finishing the setup. So for your instance, you're going to want to run through each cell. What's going on with the first one is you might get an error, and what you need to do here, like it'll be complaining about no credential or something like that. What you want to do is set this line to true, and then put in your either your username and password for your Graphistry Hub, or put in your token, your JWT token, and erase these guys. So whichever that is, then when you run it, that's going to write your credentials to a file, and then we'll just read them back in. This is just so that this is a good hygiene, so that when you share your notebook, you're not actually sharing your credentials. That would be bad, right? So just good habits from the beginning. This is kind of a code pattern you can always share. Then as part of that, so once we get then we just immediately read whatever your Graphistry creds are back in. The other thing is, depending on if you're using Graphistry Hub or RA1 for the server, you might just need to change which server you're on. It doesn't really matter. Yeah, I'll use RA1 for what I'm doing. And then when you run it, this is useful. You're seeing RAPIDS ecosystem about every 6 weeks, there's a new release, and kind of everybody, that's like kind of the new stable release for the next 6 weeks. So we're seeing cuDF, you can just check the cuDF version, that's 0.14. That one came out a few weeks ago. And then Graphistry 11.7 came out maybe a week or 2 ago. Cool, all right. So it sounds like we're good. All right, so the other thing to do, just run these 2 cells here to actually get the data. And you'll see this file folder that if it kind of runs right, it'll all fill out your files here. I thought I had already run it, so I'll run it too. And kind of you're seeing it's kind of cool in notebooks. You can just inline bash and make it repeatable. We're going to be working with Zeek logs again today. So we're just going to fill up Blazing SQL's boxes with all these logs. And then what the second one is going to do is generate kind of some samples. Often in GPU work, it's nice to have like maybe 1,000 or like 1,000,000 samples, just so that when you're doing the bigger stuff, you like, it's always good to have a test run. So the other bit, you'll see that when you're running the cell, there's a little star asterisk. That means it's running. So as that runs, you just kind of need to wait. You also see there's like a little gray dot on the top right. I forgot if that means running or it's not saved. Let's find out. Well, there's like 1,000,001 of these like little things that you don't notice. But yeah, I think that just means it's running. Okay, so I just want to give folks about a minute more to kind of catch up to what I was doing there. If you have issues with that, just poke. For the next tasks, it's going to be a little more structured how we're going to go through with them. Okay, I'm just going to watch for questions here. Yeah, maybe a little bit of background on that data set there. So we're looking at, man, I don't even remember the number of lines here. What you'll see is when we downloaded it, I think we look at how big it is. Oh, I thought we printed it. Oh yeah, we should print it near the bottom. Yeah, so we're actually only dealing with like half a gig of data here. But because we're going to be, someone has no such file direct. Okay, so remember to set false to true. That's actually going to have the code branch run. So just remember to do that. That'll actually trigger the file right, the json.dump. And so that when it tries to read it in the immediate next line, it's there. Afterwards, set it back to false, and then hide your token so that it's hidden. Okay. So still issues with that, just like post in the Slack or the YouTube. Okay. So I think if I remember right, yeah, I think we said here, it's when we decompress, it should be something like, 2 or 3 gigs of data. And I want to say it's somewhere around, I don't know, 10 million rows, something like that, maybe 50 million rows. I don't really recall. We can actually use the tool to look at it. And then what you'll see is that we have subsets, and the subsets, you can see, 1,000, 1 million, 5 million. Okay. Cool. So for the first task, this is sort of, welcome, welcome to GP coding. So the very first thing we're going to do is see if we could load in. We're going to see how much of data you can load in. And what I want you to do, like you could just run it, but the real thing to look at is like, I want you to play with NVIDIA SMI. I want to play with mostly NVIDIA SMI, and then with this guy. I want you to actually load in that data set. Like start with like 1,000, then try 5 million and see how it goes. We're using cuDF, which does not do automatic out of core stuff. So like you're gonna have to manually move stuff in and out of GPU memory. Later stuff will do doesn't need to do that, but for cuDF you have to be aware of how much you have if you're overwhelming the GPU. So how this is going to work is oh yeah, so the task is basically what I want you to see is for those data sets, like where in the memory usage, given the number of users and whatever, like how big of a data set, just without doing any magic, can you load in? And I'm going to set a little timer here for about just 5 minutes. If I can, oh, there we go. So I'm just going to do that, and then we'll circle back in 5 minutes on that one. So again, I'm going to go on mute, but the task is try the different data sets. See if you can get all the way to the full data set, and for each one, try to figure out what that limit, when you saturate memory, and kind of understand that memory usage. And I realized I missed the key detail here. When you set after we load it in to clear out the memory, you just set the pointer to that memory data set to none, and then Python will automatically remove that data. So as part of normal garbage collection, how you normally don't worry about Python data piling up, as long as we have no references to the data frame left, it should kind of clear out. So when you run that second cell, you'll kind of see how that works. And we're back. Um, so someone asks, kind of like they're a little surprised there and like, hey, so we have to manually clear the memory. So what's going on is Python, you don't, and in Rapids, you don't have to manually free the memory. You have automatic garbage collection. So just as in Python, whenever you have like a big file or whatever, as soon as all the references to it are gone, Python will automatically clear that out for you. So it's called garbage collection. Rapids works just fine in Python that way. It's just that because we end up doing a lot of big data sets, very quickly we saturate the memory. And so it's a good practice to actually be aware of how much memory you're using. And so the way to use the Python's automatic garbage collection, you basically just need to uh, just set the thing to make sure all your references are set to none, and then it'll automatically be cleared out for you. It's just in data land, you notice that much more quickly. Um, and as also as a kind of a note here, we're using for this tutorial, we're using cuDF. Uh, because cuDF, you have to manually kind of think about like, are you overwhelming? Are you using more memory than the GPU has available? So that's basically virtual memory. If you use Dask cuDF or use Blazing SQL, they automatically essentially do virtual memory for you. So they'll automatically partition file, move it around. And so it doesn't have to all fit in memory. And so, but for today, I thought it was easiest just to start with cuDF. If you join the Blazing SQL tutorial in 2 weeks, you'll kind of see what I was doing the first part of the talk, where you worry a lot less about it. Okay. So, and I think that's probably what a lot of folks saw here, that, when we were just dealing with, like, let's say 1,000,000 rows, like that fit into memory pretty good. So if I kind of ran for this, you saw that we went from like 2 gigabytes to, where is it here? Ooh, I can't read. It should have basically we're just talking about like hundreds of megabytes. And if you're on a 14 gig card, that's fine. If 32 gig card, that's fine. Same thing, like 5 million, that was pretty fine. We were able to parse it in like a second or two, pretty fine. But generally, once you start hitting 10 million, 50 million, that's when I start kind of feeling a little nervous, and that's where I kind of like want to make sure I'm doing things. Like I'll still get that speed over pandas, over Spark and everything, but now I'm like, am I overwhelming the memory? Things like that. So it's good to have that feel. Also, a little data point here. You're seeing where we're reading log files, which are essentially CSVs. It's actually even faster if you. This is actually pretty fast already because it's a GPU accelerated CSV reader. So normally that would have taken forever in like a Neo4j or Splunk or whatever. But GPU parser, so it's fast. To go even faster, to skip parsing, use something called like Parquet or Arrow. So you can actually always do, write it back out. So that's kind of a little fun. All right, so let's jump on to the next task here. So now that we're able to load it in, the question is, I want to make sure this is the task I'm thinking here. Yeah, so it's kind of getting read in a little wrong. So we're going to want to, for the next 2 tasks, we want to read it in right, and then we want to have it formatted to right. And so for the first one, when we ran it, you might have seen that we have this weird, like you're seeing it's like actually not comma separated, it's a log file, so it's actually tab separated. Sorry, I'm just reading the question here. Yeah, someone's asking, so why did con.log fail? Yeah, that's exactly it. Like we saturated cuDF, doesn't know about doing virtual memory, and so it wasn't able to spill out of like we filled up the GPU's memory, didn't know how to spill out, and so it just kind of hard crashed. So if we did something like a Dask cuDF one, or we did a Blazing SQL one, that might have worked. Syntax would be a little different. Okay, so where I want to get with that is for the next task, basically we have the problem that it's not actually a CSV, it's not comma delimited, it's actually tab delimited. We're seeing these /t's. And actually the task right after is, I want to make sure this is right. Yeah, and the task right after, like the reality is like when we actually look at all the columns it's kind of dealing with, we're going to see it's just dealing with all sorts of columns. So for the next one, I want you to first, for task B, I want you to do a tab separated read. So if you run this cell right above it, the help, you'll kind of see the option for kind of doing CSV options for different kinds of ones that the GPU parser understands, not very far from pandas. And then the second one after, what I want you to do for task 1C is I want you to fill in the file, fill in which columns we're going to load, and fill in the data types. And then I want you to look at how big of a file we can load. And basically, the first one is just about go once we have a tab separated. Actually, let me slow down. Load in the file as a tab separated one. Take a look at how much memory it's using. See if you could do the full one or not. Like see how big you can go. And then fill in the same thing for 1C. But now we're going to be a little more careful to actually, instead of just have a generic read, have a more careful structured read where we have names and types and things like that. And then again, I want you to see how much, like, does it go faster? How much memory does it take? Stuff like that. So let's see how well we could load in the data there. So I'm gonna give folks about 5 minutes there. as we go, feel free to just ask questions in the Slack or the YouTube or anything. All right, we should be finishing up the that first task in maybe 30 seconds or so. Meanwhile, I want to say a big thank you to, you might have noticed Winston's been helping out from the Rapids team, and it looks like we just got joined by Rodrigo, the CEO and founder of the Blazing SQL team. So Honored to have you with us, man. And congrats on the recent wedding. I'm gonna make you embarrassed in public. Okay. Um, you are now in the presence of a man who had the biggest Zoom wedding I've ever heard of. um, so okay, let's do a quick review here. So we did two things here. For the first one, we just loaded in tabs separated. So these are just kind of the regular pandas options. Most of them are actually already supported, which is pretty sweet. So I think it's just sep equals t. The reason I wanted to bring this one up, I thought was kind of interesting. One is, and you can always kind of run help to kind of see the options. The reason this one was cool is one is you could just do regular pandas if you're familiar with that API. But the other part is now that, for example, QDF is looking at the data, it's actually taking up less memory than if it just thought it was all a big string. So I'll kind of give a hint at that. Kind of see some of the intelligence it put into it. So when it read that CSV, woo, getting thrown around here. It's like, for example, for a lot of the, what's a good example? For port 80, like for the column with all the ports, it thought that column was all integers. So that instead of having these big strings for all of those ports, it actually automatically turned it into integers. And then that's a big, in GPU land, instead of kind of in a database where it's normally rows, in GPU land, it's actually stored as one big column. And so that's actually taking a lot less memory now. And so when you provide, when we make sure we load it in the data structured that way, it's taking less space. And then we kind of, when we go all the way to the next one here, it'll be even less space. So that should be pretty cool. Oh yeah, the other thing that to note here for that 1C is we're actually pulling out a subset of the columns. So this call subset. So let's say someone's overzealous with how much data they're recording. Then let's say instead of like 100 columns, like you record everything, but we're only pulling out, let's say 10 of them. That's first of all a lot less memory in GPU, and so all the manipulations are shorter. Just in general, things just go a lot faster. We can keep more live, more in memory, things like that. So yeah, so that's kind of a really good habit to have. So read CSVs is pretty fun. There are variants like read Parquet, read Arrow, things like that. All right, so somebody asked. I want to be clear about it. In the Slack, somebody asked, like, how do we look at CPU versus GPU? For GPU, we went over the GPU tab, but then for the CPU, I don't think we have CPU tabs here. Maybe on machine resources. Yeah, actually, we in the same place, machine resources. You can see we have CPU, and you can kind of look at. But inline, you can also just do top. And when see, it's kind of a star. It's going to kind of print every few seconds. There's a way to run top without doing that, but in this case, we're just going to hit stop. Okay, so now basically that what you should be getting a sense of is with read CSV that you can kind of have some pretty good control over how data moves in. Okay, someone's asking like why is reading a subset of columns faster? And so in the case of CSV, you still have to parse it all, but we don't need to keep it all in memory, so we can actually handle bigger data. And then in terms of parsing, I think there might be slightly clever parsing where it's like less memory pressure or something like that as it's streaming through, or it can just stop early, things like that. Like it might be able to learn this kind of things like that. When we switch formats to something like Parquet or Arrow, which are not row-based, but are actually column-based. So let's say we have like a source IP column, a dest IP column, and then maybe like the timestamp. If those are recorded, if those are actually in column representation, let's say like you have an S3 bucket with Parquet files, QDF and Blazing and all the Rapids ecosystem is actually smart enough to actually not download the columns at all. So you can actually skip it. So I would actually generally recommend store those and to begin with, or if you do get a big CSV dump, immediately convert it to a parquet. And for all or an arrow, and all subsequent analysis, just stick with those. And that's what columnar analytics buys you. Okay. So, all right, let's jump ahead. Yeah, I think this one. So yeah, now I want to do, let's do a bit of compute. I feel like these are misnumbered, but okay. So let's go to 2B. So what's going on here is kind of similar to that first tutorial piece where we, actually, Rodrigo, I see you're here. Can you whip up the exit survey here for folks after? I don't think we actually did it. So if you've got time, that'd help. But yeah, so for let's do a bit of compute. So for task 2B, this is going to be similar to what we did during the video, where a lot of analytics comes down to that same, basically filter for stuff, group by it, and do some compute on the group by. So in this case, what we're going to do is that basic thing where we're going to take all of our network traffic, we're going to combine it, bucket into basically transfers between separate IPs. So source IP to dest IP, and then for any all the flows between any pair of IPs, we're going to compute some stuff. So as some examples, we have for the timestamp, we can have like what's the first and last time that flow happened, how many unique ports happened. And what I want you to do is two things. First, I want you to, starting with a small file, try to, for the duration, figure out what the longest session is, like figure out what, like plug in values for these three right here. And max duration, bytes, whatever. And then once that's good, try bumping up to bigger files. Once you're done, come back to the Slack and then just give me a heads up. All right, so I'm gonna give folks about 5 minutes on that one, and then we'll move to data viz. All right, we should be finishing up in about 30 seconds here. All right. Yeah, and actually, I'll answer a quick question from the YouTube. So, Dark Crusader asks, how hard is it to set up Rapids on a local multi GPU environment? What we find, and I basically advocate for everybody, is use Docker. And so, what that does is you basically need to get your NVIDIA driver and your Docker, and then Docker with the NVIDIA driver set up. And you can do Ubuntu, whatever. If you actually, you could do it at home using the Lambda stack. If you go to Lambda Labs, you could do it online. You can spin up, I think NVIDIA gives out free AMIs. We have like a fully decked out ecosystem on the Graphistry Get Started if you're in a more corporate environment. But basically you get that basic just GPU driver ecosystem set up, and then do everything else within Docker. So run your notebooks in Docker, do like all that stuff. And then that way you can actually either, conda install Rapids or whatever. But by having that separation, you could burn up your Docker and just do all sorts of wild things, and it's okay because you can always just restart it. And you haven't really, and then you could only, that way you only occasionally muck with your OS level stuff. And so otherwise, it could take a lot of time. So it's fine, like when the Graphistry or Blazing or NVIDIA team muck around with that, and that's why we do these every 6 weeks releases. But within that, just stick within Docker. Kind of even here, you're in Jupyter Lab, you're actually running in Docker. Uh, yeah, and actually, they're all also asking about the data privacy. Yeah, with these notebooks. It's actually easy to do this stuff on cloud like Azure, Google, AWS. So if you go to the marketplaces, we all have those set up there. And so I think Graphistry's got Blazing and everybody. I don't know which other ones have like a fully decked out. There might be others as well. But I'd highly encourage to do private stuff that way. Okay. All right. So what I want to share here is two things. One is it's cool that this even worked. We were able to do the group by. We were able to get. Actually, somebody's asking about multi GPU. I'll get back to that in a little bit. But basically, what we were able to see here is we're able to do a group by and do a bit of compute on it. You can actually do arbitrary compute, something called Numba. If you jump into Blazing SQL, you can actually imagine writing a very similar thing in SQL using the SQL group by. And so if this looks a little weird and you don't want to do that most of the time, you can actually just write Blazing SQL and get a more sane looking version. If you look at our tutorial 1 from the first session where just when I was chatting, that will actually give you the SQL version of something very similar. Okay. And let's jump ahead here. So now for the next one, if we go to, I want to jump into visualization and a bit about data transfer here. So basically now we're at the point where we're able to read in a file. We're able to do a bit of like wrangling. If you wanted to see regex, go to that tutorial 2, I think, from today. But now that we have like a data frame with kind of like the stuff we want, like maybe we can take a look at it. So where are we in the notebook? I got a little lost. Oh yeah, I guess it is this one. Yeah. So what's going on here when we go to task 3B? I actually want you to do 2 things. So first, you're gonna kind of copy this first one out. So compute group by. I want you to make a new cell or actually it might have already been copied in, but basically I want to have a compute group by 2. And then what I want you to do is near the beginning, right after we get that file, I want you to create a subset where we only focus on port 22. So the response port 22. And then when you run that, and then when you're done running that, you're going to actually go run all the way down to here, where it's going to call that compute group by two you just did. So we're just going to have just the SSH traffic. When we're down to that, then when you're going to run Graphistry, we're running in a mode here where we set basically what's going on is you run Graphistry. We plug in that data frame you computed from that your modified, the SSH traffic one. We already set up Graphistry to say, hey, treat the source columns as like the originator header, and then the destination columns as a response header. So that's gonna be our graph from like source to dest. And then we're just gonna plot it. We set normally notebook environments, you'd set this to this run, like you'd actually say nothing here, or implicitly you'd say true. This would kind of draw a plot inline. Some reason the Blazing environment on my browser, maybe it works on your browser, was kind of not rendering it inline today. So I just set that to false, and that gave me a URL. So after you filter for port 22, compute the group on 22 ones, run through this guy. Hopefully your API key situation is fine for Graphistry, and then we're gonna do a joint session on that. All right, I'm gonna give folks like a few minutes on that. And I realize that folks are going over a little bit here. This is basically, once we get this one, we're gonna do the Graphistry stuff for 5-10 minutes, and then we're done for the day. If you're done early, just poke in the Slack, and then we can move on. All right, I lost the timer here, but hopefully that was enough. Let me see if I can find the timer here. So many tabs. Online stopwatch. Give folks about another 30 seconds. Okay. So I want folks to do two things with whatever graph they generated in that last one. I actually just ran it on the 1K data set just to kind of make progress here. So basically, when I ran it, I got the URL out. So opening that in a new tab. This could have been RA1 if folks are using RA1. If you're having issues with like the tokens or whatever at the beginning, just poke in Slack. Huh. Does not want to load. Start a new session. There's a little session tag at the end here. I'm just going to refresh, or could have just pasted in again. Not sure what was going on. Like if you get stuck at 75% on something that's, I don't know, got confused. But anyway, so we got it. I want you to open it up, and then as a fun exercise, like to try to take a look at sort of who's the top talker to see if you can zero in. It should feel a bit like Google Maps, where you can click to pan and zoom. You can always you can kind of pinch scroll, things like that. But what I want you to do is open up the data table, jump to the events list. One of the columns is going to be the total number of bytes, so you can kind of scroll to find it. But I don't know if there's like a sum bytes or something like that. So sum response bytes. Find the sum response bytes column, and then find. I want you to find visually on screen. You can always click this button to kind of zoom, put everything on screen. But what I want you to do is sort by that column, click on it, and that's going to highlight that edge. I want you to kind of zoom in and kind of center in on that one and kind of see what there is to see about it. So I'm going to be doing that here and see if you can kind of glean any information about that edge. So I'm gonna give folks about maybe 2 minutes just to play around with that, and then I'll kind of go back to how I did it and talk a little bit about it. Okay, let's close it out now. So kind of jumping in on that one. So what I was able to do was hopefully what you're able to recreate that basic flow of was able to kind of go in here. Was able to go to the we wanted to see response byte sum to see kind of for SSH who was kind of downloading the most data. And so when we did that sort, at least for the 1K logs, what I was able to do was just kind of click on that row that in turn highlighted that on screen. That got me to this guy, which was kind of interesting. And so then what I did when I looked at it was I something pretty simple. I just selected it. I was just kind of curious to see for that guy what was going on. And so when I did it, I did two things. One thing is I was just kind of curious, like which other devices, like which way the direction the data was going. So when I did for the originator, what we see is for in terms of the source is actually always that guy. But then for the response, when I kind of wanted just to page through it, you see that if we sort by that, we saw it was actually a bunch of different ones, but they're actually all internal. So that was kind of good. And then what I was starting to look at the end here is what I wanted to see is if we sort by response byte sum. The curious thing is to see like, okay, that's clearly a lot more than others, but is that to like a different computer? And so what's actually kind of interesting to me here is it's to this, and the IP range is kind of generally okay, but when I'm looking at .21, we actually do see another .21, another .21 too, but I don't know if we see another 21.253. Looks like that's the only one. So that's kind of like a little interesting to me. So like if I understood more about the network, I might want to understand, is that somebody VPN'd in or something like that. There's like, in reality, there's a lot more that you can do. Like you can always, for example, response bytes. You can always like, for example, like a way that would have made a bit more sense is for response bytes sum, like if we are looking at flows is to create a histogram out of it and then to kind of color based on the histogram to like, maybe cold to hot, something like that. That will kind of change all the edges to be cold to hot. Or maybe you need to reverse it, stuff like that. But anyway, so kind of that's sort of what we're seeing here, and they're all for this one kind of hottish. But anyway, I want to close this out. Thank you for kind of taking the journey with us here, especially for this first session. Hopefully you're able to try something new. You're able to kind of glean a little if you had tried this. So either try something new entirely. If this is the first time you're doing it, hopefully that was kind of cool, being able to load in like more memory than a GPU can hold, and running SQL and all that on a GPU. For just kind of like just closing it out. So again, thank you. We're gonna email out a little survey that we would definitely appreciate for kind of the next time we hold this. In about 2 weeks, we're going to do a session where we do, Rodrigo's going to run it on doing SQL. You're actually going to be dealing with added memories. Like, let's say you have like a terabyte of data. You'll actually be able to get a feel for what it's working with, like a lot, like way more than the GPU can hold, maybe even multi-GPU, not sure. If not on that one, it'll be in the one after. Likewise, all the materials, the opening tutorials actually be recorded too. They'll all be online. And then if you have any questions, just hit us up on Slack. We all kind of hang out in the Rapids Slack. So if you ever have questions, like we're all pretty clearly excited by this stuff. So thanks again, everyone. I'll hang out a bit more for some questions and stuff. Actually, I remembered I want to share one last thing. We're also we want to do another couple of like online ones, but if you're part of a bigger team, like at like a lot of developers or a lot of analysts, we also want to start experimenting with doing private trainings. So if that's kind of an interesting thing to your team, We probably can only really do it when there's like a lot of people involved. But if that's a potential thing, just hit us up on that as well. All right, thanks everyone. Bye. And with that, I am ending the stream.